Hello students, today in chapter 5 we are going to learn about the concept of a straight line. Now before we dive into the exercise, we need to learn certain basic things. We start with learning what is the meaning of intercept of a line. Now in this diagram, in this figure, consider this as a line, say this is line L. And this line L, suppose it meets the x-axis in this particular point, that is say a comma 0, and it meets the y-axis, it touches the y-axis at this particular point, say 0 comma b. Then in this case a is called as the x-intercept of the line. So a is the x-intercept of the line, and similarly b is known as the y-intercept of the line. So b is the y-intercept. So that means the x or the y-intercept of a line is basically that particular coordinate at which the line touches the x or the y-axis that is there. Now suppose a line is parallel to the x-axis. Suppose you have the x and y-axis this way. Suppose let me draw the line this way now. Over here the y-axis and the x-axis. Now suppose a line is there which is parallel to the x-axis. Suppose this line is parallel to the x-axis. Where does it meet the x-axis? It does not meet the x-axis at all. So this line has no x-intercept. So x-intercept of this line is not there. Similarly, if we draw a line which is parallel to y-axis, naturally that line does not meet the y-axis anywhere, and therefore this particular line does not have y-intercept. So it does not have any y-intercept. So a line parallel to x-axis does not have an x-intercept. Similarly, a line parallel to x-axis, y-axis does not have a y-intercept also. So that is regarding the intercepts of a line. Now the next concept, that is inclination of a line. Remember properly. Now, so first of all, let us go to the definition of the inclination. The smallest angle made by a line with the positive direction of the x-axis measured in anti-clockwise sense is called as the inclination of the line. Now take the first figure over here. In this first figure, this is the line, say this is line L, and this line is making two angles, isn't it, with the x-axis. You'll think that okay, this line makes two angles with the x-axis. Which one is the inclination now? See, this line is making this angle theta, and similarly one more angle, this angle is made by this line as well, which is actually 180 minus theta. So which one is the inclination? Yes, we take the angle made by the line in the anti-clockwise direction with the x-axis. That means this is the inclination of the line, because this is made in the measured in the anti-clockwise sense. Okay, this angle is measured in the anti-clockwise sense. So therefore this angle theta is called as the inclination of the line and not this angle. Similarly, go to the next figure. In this particular figure also, this line, say line M, makes angle alpha and also makes another angle, say 180 minus alpha, with the x-axis. Which one is the inclination of the line M? Yes, it is this particular angle which is measured in the anti-clockwise sense. So the smallest angle made by the line with the x-axis measured in the anti-clockwise direction is called as the inclination of that particular line that is there. Now over here, remember that the inclination of a line is an angle which comes between 0 and 180. So we have 0 less than or equal to theta, which is less than or equal to 180 degree. So the inclination may be an acute angle or an obtuse angle, but always the inclination is positive. Okay, it is always measured in anti-clockwise direction and it comes between 0 and 180 degree. Now here, an additional thing which I want to tell you is, suppose you consider parallel lines. Suppose for this particular line, suppose we draw another line which is parallel to this particular line over here. clearly we can see that this line, the new line which I have drawn over here, say M1, this line makes the same angle alpha with the x-axis as made by line M. That means both of them have the same inclination. As you can see, alpha and this particular angle, both are corresponding angles. You know that corresponding angles are equal. And therefore, parallel lines have the same inclination. So, this is something which you have to keep in mind. Similarly, what about the inclination of the x-axis? What angle does the x-axis make with itself? Okay, suppose I draw a fresh graph just to make you all understand this. What angle does this x-axis, this is the x-axis, what angle does the x-axis make with itself? X-axis makes angle 0 degree with itself. And therefore, we can say that the inclination of the x-axis, let me write over here, the inclination of the x-axis is 0 because it makes angle 0 degree with itself. Any other line which is parallel to x-axis also will have an inclination of 0. Similarly, what is the inclination of the y-axis? Look in this figure. The y-axis makes an angle 90 degree with the positive x-axis, isn't it? This makes an angle of 90 degree with the positive x-axis. And therefore, the inclination of the y-axis or the inclination of any other line which is parallel to the y-axis is actually 90 degree. Keep this in mind actually. Now that you have learned what is the meaning of inclination of a line, we can go to the further concept which will be understood only if you understand what is inclination. That is, we come to what is the meaning of slope of a line. Now, if the inclination of a line is theta, what is the meaning of that? Yes, if the angle made by the line with the positive x-axis is theta, then tan theta, tan of that angle, if it exists, because you know that tan theta may or may not exist. Tan of certain angles does not exist. So, tan theta, if it exists, is called as the slope of the line. Remember this, tan theta is called as the slope of the line. Now, commonly we call it as M. Slope of the line is called as M. Now, remember that the slope of a line tells us how steep the line actually is. It tells us regarding the steepness of a line. For example, a line may be this way. If it is steeper, it may be this way. It may be like this. It may be this way, whatever. So, from the value of slope, we get an idea about the steepness of the line that is there. So, one way of finding the slope is by taking M is equal to tan theta. If we have an idea of the inclination of the line, that is theta. If we know theta, then of course we can take tan theta as the slope of the line. Now, what about the conditions? There are certain sums where we do not know what is theta. So, how do you find the slope then? In that case, I am going to teach you a formula, one more formula for the slope of a line. Now, consider this particular figure. In this figure, suppose P has the coordinates x1, y1 and Q has the coordinates x2, y2, and these two are points of a line. P and Q are points on a line. Say this line is line L. Now, in this case, the line has inclination theta. The line has an inclination theta. It makes an angle theta with a positive x-axis. Now, because this angle is theta, angle QPR, which is a corresponding angle with this angle, is also theta. So, the measure of QPR is also theta. Also, we are going to, just to prove the concept, we are going to draw two perpendicular lines. See, we are going to draw QM, which is perpendicular to the x-axis. We are also going to draw PR, which is perpendicular to QM. These have already been drawn over here. You can just take a look here. So, angle RPQ is theta. So, since angle RPQ, we have angle RPQ is equal to theta, and therefore, the slope of the line L is making angle theta with the x-axis. Therefore, we have slope of the line L as tan theta. Say this is known to us right now. Now also consider triangle PQR. In this triangle PQR. Now before considering triangle PQR, let us see a few things over here now. See, the y coordinate of point Q is y2. The y coordinate of point Q is y2, which means this distance, that is QM, the distance QM, length QM is going to be y2. So this much is going to be y2 in this case. Then similarly, the y coordinate of point P is y1. That means this much distance is y1. Okay, from here to here it is y1, or rather this much is y1. This is y1. So if this distance is y2 and this is y1, what is this distance then? What is RQ? Obviously RQ will be RQ or QR, whatever way you take it, will be y2 minus y1. Okay, understand that RQ is equal to y2 minus y1. Similarly in this case, let us take the x coordinates now. The x coordinate of Q is x2. That means this distance is x2. Now this is clear from the figure, I guess, isn't it? This distance is x2 and similarly this much is x1. Similarly, in the same way, this much is x1. That means PR is x2 minus x1. Okay, PR is x2 minus x1. So we write over here PR is equal to x2 minus x1. Now having said that, in triangle PQR, okay, take the triangle PQR. Consider this particular triangle PQR. Now in this particular triangle, what is tan theta? Tan theta, you know the formula for tan. According to trigonometry, tan theta will be opposite upon adjacent. Opposite upon adjacent. That means RQ upon PR. Okay, it is opposite upon adjacent. Now we already know what is RQ, isn't it? RQ is y2 minus y1. So therefore, let me write it over here, which is y2 minus y1, and PR is x2 minus x1. Suppose this is, say, our second statement. Compare 1 and 2. So in 1, tan theta is m. In 2, tan theta is y2 minus y1 upon x2 minus x1. And therefore, we can say that m is equal to another formula. We get the second formula for measuring the slope. So we have m, that is the slope, is equal to y2 minus y1 upon x2 minus x1. So thus this gives us the second and important formula for measuring the slope of a line. Often we are not given the inclination of the line. Theta may not be given to us often. That means we are left with this particular formula that is there. Okay, so here we have learned two formulae for measuring the slope of a line. Slope is either tan theta, or in the same way slope is the subtraction difference between y1, y2 and y1 upon x2 minus x1. Now, what is the slope of the y-axis? Slope of the y-axis. If you remember the inclination of the y-axis, what is the inclination of the y-axis? Yes, the inclination of the y-axis is 90 degree. So slope of the y-axis, theoretically it should be tan 90. But then tan 90 is not defined. It is not defined, isn't it? It is sin 90 upon cos 90. Cos 90 is 0. Anything upon 0 is not defined. That means since tan 90 is not defined, slope of the y-axis is also not defined. In the same way, what is the slope of the x-axis? Now, the slope of the x-axis has an inclination 0, isn't it? So, slope of the x-axis tan 0, and tan 0 is 0, and therefore slope of the x-axis becomes 0. So, the slope of the y-axis or any line which is parallel to the y-axis is not defined, and the slope of the x-axis or any other line which is parallel to x-axis is 0. Similarly, parallel lines, if two lines are parallel to each other, suppose these are two lines which are parallel to each other, they will have equal slope. So parallel lines have equal slopes. Keep all these points in mind. They will come in useful to you when you solve sums. Before we go any further, I thought we will just start with the exercise 5.2 and see what type of sums are given which deal with the slope, inclination, etc. Question number 1 in that, find the slope of each of the following lines which passes through the points. Now certain points are given over here. For example, in the first question, A is 2, -1 and B is 4, 3. So 2 points are given. So slope is given by this particular formula. Slope is m. M is equal to y2 minus y1. I hope your notebooks are open so that you can do the sums along with me. Upon x2 minus x1. Using this particular formula, we can write this as y2 minus y1. Suppose we take 3 as y2. So 3 minus minus 1. Take corresponding points only. If you take 3 as y2, then 4 will be x2 in this case. Upon 4 minus 2, which comes out as 3 plus 1 upon 2, which is 4 upon 2, which is 2. So thus, the slope comes out as 2 in this case. Same way, let me help you with the next sum also. In this case, what is the slope? Using the same formula, y2 minus y1 upon x2 minus x1. We are going to get 7 minus 3 upon 5 minus minus 2, which is 4 upon 7. So this becomes the slope. Now there are two more questions of this type given, sum number C and D. This you can practice it as homework or finish it off just now, right now, and then go on to the next sum which I am going to solve with you. So question 2, if the x and y intercepts of line L are 2 and 3 respectively, then find the slope of line L. Suppose this is a line L given over here. The x-intercept of line L is 2. That means line L touches the x-axis at say 0, 2. I'm sorry, it is 2, 0. X coordinate always first, so 2, 0. Similarly, suppose line L touches the y-axis at 3. The y-intercept is 3, given as 3. That means the line L touches the y-axis at this point, that is 0, 3. So we have 2 points on the line. That means we can easily find the slope of this line. So slope of the line which is given as m and which is y2 minus y1 upon x2 minus x1. Incidentally, even if you write x1 y1 minus y2 upon x1 minus x2, it is one and the same thing. Think about it. So y2 minus y1, suppose we take this point as x1 y1 and this point as x2 y2. So we have 3 minus 0 upon 0 minus 2, which comes out as 3 upon minus 2, which can be written as minus 3 upon 2, and this becomes the slope of this line. Easy, isn't it? Now question number 5 of the same exercise 5.2 is a sum which is similar to second sum. So this sum you are going to solve it as homework. We go to the next sum. In this case, find the slope of the line whose inclination is 30 degree. That means theta is 30 degree. So here theta is given as 30, and therefore what is the slope of this line? Slope is given as tan theta, and therefore slope, which is m, is equal to tan 30. This is where your trigonometry comes in, useful for you. Tan 30 is 1 upon root 3. So thus this becomes our answer. Same way we can do the next sum also. Find the slope of the line whose inclination is pi by 4. Here theta is equal to pi by 4 and therefore slope of the line, that is m, is equal to tan theta, which is tan pi by 4. Now what is pi by 4? When we convert pi by 4 into degrees, it becomes 45 degree. So tan 45, tan pi by 4 is tan 45. Remember, very often in all your classes, angles will be measured in radians, and therefore you should be thorough with what is pi by 4, pi, etc. So tan pi by 4 means tan 45, which is 1. And thus the slope of the line comes as 1. So the first 5 sums of the exercise 5.2 are done. The next sum deals with the next concept, which we will begin later on in the next lecture. So keep practicing. Thank you so much for listening, students.